Well, good morning. Almost good afternoon. Sorry about that. For those of you who are used to DFW area, you know the traffic out here can be as bad as Houston, if possible. I apologize for being late, and unfortunately, I thought what would have been a 45-minute ride turned into about an hour and a half. So there's a two-car accident at Marsh and 635. Let me just do a little polling first. How many people are with utilities right now, i.e. water, wastewater utility? Anybody working for a government agency? Local? Oh, this is going to be a good crowd. Okay. We made some very strong decisions several years ago about where we wanted to be as far as power went. Oh, I do see some familiar faces though. And in doing so, we have achieved a level of reduction in power at our wastewater treatment plant that we thought was possible, that we've proven it to ourselves. And now our next step is to go for net zero. We are trying to be completely independent of the power company. Okay, so let's start with that. If you all know the area, Fort Worth has one wastewater plant, and it's over there on the east side of town. Originally it was a little 5 MGD plant in 1957-58. It is now permitted at 166 MGD. Our average is about 105. But we look at it as a stepping stone for where we need to be. I will note that the single stage activated sludge and nitrification is the process that we use. And for those of you with water backgrounds on wastewater in particular, we do anaerobic digestion for our solids. And anaerobic digestion is where we really picked up a lot of speed. This is the plant. I don't know if you can see it real well, but the red was what was the first plant. That was the 5 MGD. Then we went 72 into 45. We started adding more clarifiers, more digesters, more filters, a new chlorine contact basin. Then in 1980 we added the aeration basins, some sedimentary tanks, some deep filters, some more clarifiers, and some primaries. 88, we got a little more aggressive. We picked up another. Oh, yeah, sorry. Can you hear me better now? Okay. Do you want me to start over? No. Good. I don't remember what I said. Anyway, 88, we finally got the 120 permit, and then 1999 was our next big jump. We added some more primaries, some trickling filters, the brand new chlorine contact basins, some more filters here also, and then the GBT, or the DAFs down here on the left. 2005 came our expansion for the purpose of handling high flow rates. We were seeing a lot of infiltration into the system. One, we fixed the system, the collection system, and two, we gave ourselves some capacity. Too close. There we go. Like I said, liquid processing is aerobic. It's a preliminary screening, which was the brown section. There's a primary sedimentation, a secondary advanced, and then discharge. We discharge our effluent to the Trinity River, which eventually makes its way down through the state to Lake Livingston down north of Houston. The solids processing, we've been doing this for years, is land applied. once it's been treated properly. We look at energy and wastewater together as a way to resolve multiple issues. Typically, this breaks into 4 categories. We do reuse water. We just built a line all the way from Village Creek to DFW. So if you flew into DFW, all the grass out there is watered with reuse piping. And we're also trying to work with them on doing the cooling towers at the center of the airport. We generate a lot of biogas, which we then convert to power. We generate biosolids, which we land apply for the farmers. And then, like I said, the balance of the water that we don't use for reuse, we actually put back into the Trinity River at this point in time. We had a project, and this came to us from Johnson Controls. We were under contract with them to do modifications to all the facilities other than the treatment plants. They were replacing light bulbs and lights and your standard product type stuff. And we had a get-together with some of their process people, and we said, hey, can we do something with the power that we generate? Because when we did the conversion for the turbines, well, all of a sudden we went to 5 megawatt turbines. That's almost, when you get both of them running, total power for the plant. So they said, well, yeah, we can, but it's going to make it, you're going to have to do some things a little differently. First off, you're going to have to turn off the electric motor blowers. They are the biggest consumer of power at the plant right now, okay? That was pretty tricky, but the engineering companies that were helping us out came up with an idea. They said, yeah, we can take those out of service, and what we'll do is take the gas turbine waste heat and turn it into steam. And then the steam is used to power turbines for our aeration basins. So the single largest consumer of power on the plant site all of a sudden becomes a steam-driven system. Okay, and that made a huge difference. Matter of fact, it was one of the 2-year returns, in essence. The let me back up a second. We also were told that we had to stop wasting our methane gas. The digesters produce methane gas. So the methane gas became the source of power for the turbines. So I'm not off-site still, I'm still on-site. Then we would convert the turbine power to steam generation with the waste heat, which is what you see here. And then from the waste heat, we would drive the steam engines. So it's all one process, it's all on site, and it has a reduction in our purchasing of power from the grid. Now, my plant manager would like to tell you that his goal in life, as far as the plant goes, is not only to be net zero, but to feed back to the grid with the excess power. So we're going to try and see what we can do about that. It does mean having to do some more work on some of our digesters. The title here, Journey to Net Zero, began in the 60s, was when we actually put our first engine generator set in. It wasn't turbine. It was a diesel-style power generator, but it was still using methane, okay? Then in 02 is when we actually converted to these turbines. And you can see the turbines lined up right here. Well, turbines are effective as long as you use them at their maximum load, okay? If you go down into 30% on it doesn't become as effective. So what we did was we powered up one completely, and then we used the other as backup or as a demand type source. The phase that got involved here was when JCI went ahead and said, okay, here's all the projects you can do that will effectively reduce your consumption of power. So, new bifocals. The FIMs are the actual projects. So we did a conversion. Actually, if I can use this. Whoop. Where's the laser? Ah, there we go. FIM 1 was the aeration diffusers. So we took those out and replaced them. Fine bubble. So, they're not ceramic, they're the flexible. Okay. Then the FIM 2, if I can find it, is the heat recovery, which is the light blue. For those of you who are watching on the other screen over there, let's see, oh man, distance right in here. Okay, and then these were the aeration basins. The 3 turned out to be an improvement on the digesters themselves. It's the light blue on the bottom. It's called linear mixers. Are you all familiar with linear mixers? You know how sometimes you take water in a pool and you push your hand down real quick and it shoots up a jet? Well, it's the same fundamental principle. Instead of putting these big paddle wheels inside of a digester, we'd had an 18-inch stroke on a linear mixer that just went up and down real slow. Otherwise, it probably would have blown the walls out. But it works tremendously. It keeps all the solids in suspension. The 4, where's my 4? Whoop. 4 is the yellow, which is the new SCADA system. We were on an antiquated system. Matter of fact, we were scavenging parts from various locations inside the plant just to keep the main computer running. It was an old Allen Bradley. And then 5 was the anoxic zones that we put on the aeration basins. That means the first chamber allows to do it without oxygen. It's oxygen starved in essence. And then 6A is the aeration control improvements. And 6E was the HVAC, 6D pump operation controls, and then 6H was power factor corrections. So in essence, we had multiple engineers under the auspices of an overall company, which was Johnson Controls, doing all these on site simultaneously. And they had to keep the plant running. They couldn't have a notice of violation of any kind, and we managed to keep our platinum status for the plant. So they did pretty good. Oh, wait a minute. They did very good. Since there's 2 JCI people in here, I don't want them to think I'm... Okay, so what did we see? Well, we got down the road and we said, okay, this is great. And everything was looking good. And we realized that if we just had enough methane to get that second turbine running full speed, we'd be able to operate the entire plant. So we're looking at doing that now as part of phase 2. One of the big challenges happens to be financing. That's the reason I asked if there are any utility people here. Typically, utilities will either go cash or debt financing. The interesting thing about this first phase that we did, and with the help of JCI, is instead of encumbering new debt, We talked them into letting us have a municipal lease on all the equipment. Well, for those of you who do financing and operations, you know that municipal leases don't count towards your debt, especially when the funding is being offset by reduction of the electric power. So in essence, we had an ability to fund the project, half of it. I paid cash for half. The other half we did with the municipal lease. And we took the offsetting power costs and used that to pay for the lease. So in essence, it didn't change my debt structure at all, and I didn't have to ask for a rate increase. So that was a big Benny. And this thing lists a couple of the items here that we're looking at. And of course, my finance people put some of this together. So the debt financing for capital funds, that's a standard. Rate structure and levels, that's a standard. Energy saving performance contract again, which is the ESPC, is the way we're going to probably go again. And targeted creative financing options, which we consider the municipal lease as creative, because there's not too many plans to do municipal leases on heavy equipment that's stationary, bolted into place, or new filter heads on a piping system that in essence you're renting or leasing, and if you don't pay, they're going to have to take it out. Well, try taking out some aerators. It's a tough thing to do, okay? So, yeah, don't try and swim in that aerated water though, right? Okay. Actually, a friend of mine told me that if you jump into an aerated basin, and this is without sludge or sewage, that you'll sink. But my boss proved him wrong. He swam around the tank for a while. It was a hot day in Florida that day. $37 million is the total cost. We're saving about $2.8 million a year. $2.8 million turns into a 13-year turnaround. What happened was the power stuff actually has a shorter life expectancy, as you can see. The one that ended up costing us on time was the diffusers, because there's just so many of them, you have to keep cleaning them and stuff like that. There's maintenance issues involved with that. I just thought you might like to see what the heat exhaust duct burners, or the HRSG, would look like. This is outside the plant. It is hot. I mean, really hot. And then the one on the left is where we took the blowers out, the electric ones. One on the right is the steam-driven ones. The one thing that was required to do this through the ESPC route was that we had to do measurement and verification. So every year we had to go back, check the power, see how much we used, and report it back to the agency, so that way we get the credit necessary. It's also how we put the payback. We have a guarantee. They probably don't want me to tell you this, but we have a guarantee that if we don't meet the power reduction that was identified in the original report, they have to pay the difference. So if I come up at 2.4 million instead of 2.6 million, they're going to have to cover my extra $200,000. So that's another aspect of this that made it sell real well to the management people. It's all standard protocol. And it also, the last bullet on here is the important part. Having to do measurement and verification forces the employees to stay involved, to make sure they're watching everything, because JCI could turn around and say, hey, you turned off X, and that's why you didn't get your power. So we have to watch it just as much as they do. And just to give you a simple drawing here, this is from 98 to the start of the year 14. You can see where our power consumption is and where our purchase is. And we're dropping off real quick right now. I'm down to the last two. Okay? So if you're looking for a methodology, if you have the ability, if you have access, or if you're going to go back and tell some people at the city that you ought to consider something, we found this to be a very good way to get things done. So you can see where the turbines are, where the ESPC began, and now when the turbine blowers came online, and now the balance of the equipment came online. And we're down to less than 2 million kilowatt hours now. Don't forget to include TCEQ if you're in Texas. I don't know what the agencies are for the other states. Don't forget to mention it to EPA. They like to hear about this kind of stuff, and DOE. The Department of Energy, and then we also have done several presentations at WEF and NACWA and WRF. So we try to keep as visible. I think that's what you were saying about staying visible, so everybody knows what you're doing. We published several items. The energy roadmap is one of the documents that's come out of this. It actually came out almost simultaneously. And you can see, if this is big enough to read. So right now, with 2 years, we've got about 6 million benefit to it. Not bad for an agency that has to compete with every other department in a city. Of course, we are an enterprise fund compared to, told you there's only 2 more slides. With that, I'll close. I will mention, though, that as far as reuse goes, we're doing reuse at about 2 million gallons a day right now. And we supply with a golf course between here and DFW. And we've made a real strong concerted effort towards conservation. So that's changed our average flow rates at the plant. And that has been a benefit also, although it's making my biosolids harder to deal with.